Hello, in this last video for chapter 3, we are going to learn how to calculate the formula mass for an ionic compound. It's super easy. We're just going to add the masses of each individual atom in the formula of a compound. So for example, let's start with our favorite ionic compound, sodium chloride, which is just table salt. So what we'll do is we'll look on the periodic table, and remember, right under the symbol for sodium should be the mass, which is 22.99 atomic mass units. So we'll also do the same thing for chlorine. So if we look at chlorine's mass on the periodic table, right under the symbol for chlorine, it should say 35.45 atomic mass units. Now, some versions of the periodic table will give you 4 significant figures. Some will give you 5. So just go with what your periodic table gives you, and you'll still get a very, very similar answer, even if you have 5 sig figs versus 4 sig figs. So in this case, I'm using a version that has 4 sig figs, but again, all we have to do is just add these two masses together. So if we plug that into our calculator, we should get an overall mass of 58.44 atomic mass units. Now, you might be wondering, do I have to adjust for the fact that sodium lost an electron and chlorine gained an electron when they became ions? But remember, electrons have negligible mass, so it's really, really small. So if we lose an electron or gain an electron, it really doesn't make a difference to the overall mass for the atom. Because again, the mass is coming from the protons and the neutrons in the nucleus, and those have not changed. All right, so let's do another example. Let's look at calcium and fluoride. So if an ionic compound has more than one anion or more than one cation, we have to remember to multiply it by the appropriate amount. So for example, for calcium fluoride, we have calcium plus 2 ion, and then the fluoride ion is a negative 1 ion. So we actually need 2 of them in order to balance the charge on calcium. So the overall formula is CaF2. So that means that we do need to multiply the mass of the fluoride ion by 2. So down below you can see that the mass of calcium on the periodic table is 40.08 atomic mass units. And the mass of fluorine on the periodic table is 19. But since we have 2 fluoride ions, we do need to multiply that mass by 2. So that will give us a total of 38 atomic mass units. Now, if we plug this into our calculators and we add 40.08 and 38, we get a total mass for this compound equal to 78.08 atomic mass units. So that would be the formula mass for calcium fluoride. All right, so let's practice. See if you can calculate the formula mass for the following. And again, you can find the mass of each atom on the periodic table. So you'll probably need to pull up a copy of that. So pause the video, see if you can figure out the masses, and then we'll go over it together. All right, so let's see if we got the same answers. So let's see, the first example we have copper and chlorine. So copper's mass is 63.55 atomic mass units. And we only have one copper, so we don't need to multiply that by anything. And then we already saw that chlorine's mass is 35.45 atomic mass units. So we're just going to add those together. And my calculator gave me 98.99 atomic mass units. So hopefully you got the same thing. If you didn't, just double check that you were looking at the right element on the periodic table and that you got the right mass. And sometimes too, I know I enter things into my calculator wrong. Sometimes I just, hit the wrong button. So if you didn't get the same thing, just double check. The next one, magnesium bromide. So we have one magnesium ion, and magnesium has a mass of 24.30 atomic mass units. And then it looks like we have two bromide ions. So I'm just going to put parentheses here and multiply bromide or bromine's mass by 2. And bromine's mass on the periodic table is 79.90 atomic mass units. All right, so plugging that in, I got a mass of 184.1 atomic mass units. All right, the last one, we have aluminum oxide. So this was an example we saw before. There's two aluminum atoms, or ions, I should say. So we need to multiply the mass of aluminum by 2. And it looks like the mass of aluminum is 26.98 AMU. And then we have 3 oxide ions. And the mass of oxygen is 15.99 AMU. Now, sometimes, depending on the version of the periodic table you have, they'll list oxygen's mass as just 16. And then others will keep it at 15.99. But it's just a difference of 0.01. So you should still get the same answer even if you used 16 AMU. All right, so the final mass here, we get 101.96 AMU. So not too bad, right? You just kind of have to keep track of how many of each atom you have. And that's why it's important to know the charges of your ions so that you get an accurate molecular formula, because we want to make sure we're getting an accurate mass for our compounds. Later on, we're going to use these masses in calculations, so it is important to have accurate masses. Now, what if we have an ionic compound that contains a polyatomic ion? So we do need to include the number and mass of each atom again. And this is why it's also important to know the formulas for the polyatomic ions, because that makes sure we get an accurate mass, right? So let's look at an example. Here we have potassium nitrate. So remember, potassium has the symbol K. That's probably coming from its original name. That was most likely in Latin or Greek. And then we have our polyatomic ion NO3, which is nitrate. So potassium has a +1 charge. Nitrate has a -1 charge. So they perfectly balance each other. Now we only have one potassium. So the mass of potassium is 39.10 atomic mass units. And then we only have one nitrogen in the nitrate polyatomic ion. So that has a mass of 14.01. And it looks like we have 3 oxygens. So we need to multiply the mass of oxygen by 3. So notice here, oxygen is listed as having a mass of 16 instead of 15.99. So again, it's going to vary depending on your periodic table. So 16 times 3, that gives us 48. So now we're just going to add all of those values together, and we get a total of 101.11 AMU. Now, what if we have a situation where there's multiple polyatomic ions in our formula? So, for example, let's look at calcium nitrate. So there's only one calcium, and then we have NO3, but there's 2 of them. So what we have to do is carry that 2 into our parentheses. So that means we have 1 calcium, 2 nitrogens, and 6 oxygens, because we have 2 times the 1 nitrogen and 3 times the, 2 times the 3 oxygens. All right, so we have to be careful when we have multiple polyatomic ions. We want to make sure that we're calculating the right number here. So calcium, again, has a mass of 40.08, and there's only one of those. But now we have 2 nitrogens, so we need to multiply the mass of nitrogen by 2. And we have 6 oxygens, so we need to multiply the mass of oxygen by 6. So for the nitrogens, we get a total of 28.02, and for oxygen, we get a total of 96. So we're going to add all of those values together, and that will give us a total formula mass of 164.1 AMU. All right, so now it's your turn to practice calculating these formula masses. So here I've given you 2 ionic compounds that contain polyatomic ions. So see if you can calculate those formula masses. You can pause the video, and then when you're done, unpause, and we'll see if we got the same answer. Okay, let's look at the first one. So we have calcium, and then the polyatomic ion is called hydroxide. So notice that we don't have to indicate how many hydroxide ions we have in the name, because hydroxide will always have the same charge. So we just name it as it is, calcium hydroxide. Okay, now it does look like we have 2 of them, so we want to make sure to carry that 2 into our parentheses. So we have 1 calcium, and its mass is 40.08 AMU. And then we have 2 oxygens. So we'll multiply by 16, or 2 by 16. And then we have 2 hydrogens. So the mass of hydrogen is 1.008. So we'll multiply that by 2. Okay, if we add all of that together, our calculator should give us 74.09 AMU. Let's look at the next one. This one is called ammonium sulfate. So this first part is the ammonium polyatomic ion. It's the only one that has a positive charge, actually. And then this SO4 is sulfate. All right, so notice that we do have a 2 outside of our ammonium parentheses here. So we do want to multiply nitrogen by 2. And we have 4 hydrogens, but we want to multiply that by 2 as well. So we actually have 8 hydrogens. Okay, so let's start there. We'll multiply the mass of nitrogen by 2. So the mass of nitrogen is 14.01. And then we'll add 8 times the mass of hydrogen, which was 1.008. And now we're getting into sulfate. There's only one sulfate polyatomic ion, so we don't need to multiply by crazy numbers here. It looks like we just have one sulfur, and its mass is 32.06. And then finally we have oxygen, and there's 4 oxygens. So we'll multiply the mass of oxygen by 4. Okay, so putting that all into our calculator, we should get a mass of 132.1 AMU. All right, so hopefully that's not too bad. If you do have any questions, always feel free to message me, or you can ask me during class. And I will see you in chapter 4, which again is all about covalent bonding. I'll see you then.